CV. And the watermark we're going to build is going to look just like this. Now this seems like it should be a trivial task, right? It seems like we should just be able to just drop an image anywhere on our video and then boom, it's done, and then add some transparency to it. Perhaps in the future it will be that easy, but for now it's actually not. It's actually a little bit more complicated than that. So we'll talk about all the things that need to be done to make a watermark, and that is of course a transparent watermark, much like you might see on YouTube. Of course it's not like YouTube because it's not clickable. This is more for if you have like some security cam footage and you want to put a watermark there, or if you have a bunch of images that you want to put a watermark on as well. This method will work for both of those things. Now, but before we jump in, I just wanted to mention that I have a new utilities module that's going to help speed up things for us. So if you did the record video, if you did the record video module in the record video, you'll know, and the video I'm referring to is this one, this OpenCV tutorial on recording video in OpenCV. Wow, that's a lot of mouthful. You'll know that we had a bunch of parameters that we set to record that video. So what I did was I made a class that will do that for us. And that's this CV video configuration. So basically we call this, we do some initial setup, and then all of those same sort of parameters will come back for us. And this will probably be improved. So over time, it will be improved. And if you need, just go to our GitHub, joincv.com/GitHub, and look for that OpenCV Python series. And inside of SRC, you will see a utilities file. Most likely, I mean, I might, if I do update it and if it's major, I will probably talk about it in a future video, and hopefully I'll remember to put notes on this actually utility module itself. But again, all we did was adapt the code from the recordvideo.py. So worst case scenario, you just go back to that video and use that code too, because this one will most likely not change. Okay, so without further ado, let's go ahead and get started. Now I have this utilities file here, and I'm importing it into roughly what my base recording would look like, right? So in base.py, this is it. So I just added a few things in there for it. I still kept frames per second outside of that main configuration, just because that's required for this CV video writer. Where the other things were about changing the size of the video and then also what the video type would be, just by using this one simple line. Perhaps OpenCV has something like that that's super easy like this, but I actually haven't seen it, so I wanted to make my own. So now with this, all it's going to do is make a watermark.mp4 file for me with a resolution of 720, because that's what my camera can do, and a frames per second of 24. Now, if your frames per second aren't actually working with this video writer, there's a chance that maybe your actual video or your camera can't do those frames per second. That is a possibility for that. But I will be researching more as to why some of you may have had issues with the frames per second problem. If you know of solutions, please let us know in the comments, but that's my intuition as to what it would be. Okay, so now into my project. Now I'm just going to go ahead and run python watermark.py. I'll hit enter, and what I see is a 720 video. And obviously there's no watermark, there's nothing there. And if I close it out, what I should see in my saved media is that file is actually there, right? And it should be of the right size. For right now, it is wanting to be stuck. Little glitch in my computer there. But it should be at 720 of full resolution. Of course, your computer, depending on your computer, you might be able to make it bigger. And again, I'm still getting these errors, but it is recording it in MP4. Which is great. Okay, so I have everything set up ready to actually start doing the process of getting the image and putting it in as a watermark. Now, if you cloned our repo, you'll see that I have a logo in here for the watermark I'm going to be using. So there's actually two versions of it. One's a PNG file, one is a JPEG file. I only have these two so you can see the difference in them when you test them out on your own. One of them actually has a transparent background. Now that's the tricky part here. Like we only want to show the actual coffee mug and no whiteness around it. So we'll see what those things do once we get there. So first and foremost, what I need to do is I need to bring this actual image in, right? So let's go ahead and do that. First of all, I'm going to call it the watermark, right? So watermark equals to CV2. And we want to actually just load in the path where this watermark is. So img or im read. And where is this actual image path? Well, it might be different for everyone, but more than likely you're going to have it inside of src, images, logo, and then the name. So I'll just say the img path equals to, and img or images slash logo slash CFE coffee, and I'll start with JPEG. Okay, so we want to read that. And I want to get the raw file itself, so I'll just do a -1. I'll explain this in just a moment, but essentially we want to have multiple channels for this image. So we have this image being read. Let's go ahead and just look at it. We'll just do cv2.im_show, and we'll say watermark, and we'll say watermark. Okay. I'm going to turn off the recording for now, so we'll wait on the recording for a little while, actually. So I'll save that and jump back in and just run python watermark.py. And what should happen is we should see our watermark image as well as our video. Okay, so what I want to do is I want to bring this watermark and put it right down here at the bottom. All right, so yes, this is way more challenging than you might think. But another thing I want to do is I want that watermark to be a different size. I actually want to resize it, right? So right now it's way too big. I want it to fit down here in this corner. So how do we do this? Well, there's a few different ways, but I actually created a utility for this reason. Actually, I didn't create it. I got it from a GitHub or a Stack Overflow post about this very problem because it's a fairly common one. And this was just really nice and it has a lot of explanation to it. So I ended up using that one. You could go through it if you'd like, but essentially what it's doing is looking for the image size, and then it's going to change it based on if you give a height or a width, and then it will actually add those things. Or it'll just give you the default size, which is cool. So let's go ahead and import it. Back into my watermark, I'm going to go ahead and import image resize. Okay, so what I want to do is my watermark, instead of calling it watermark yet, I'll just call that logo. And then the actual watermark will be the resized version of that. So we'll say watermark equals to image resize. And we want to get the logo. And then we want to change it based off of height or width. Either one. Doesn't really matter there. It's kind of up to you on that one. Okay, so now I can actually show this image and we should see a much different size. So we show it. Watermark, and where'd it go? Yeah, there it is. So now it's like tiny, right? So we see that it's working. And the way this does is it's going to be related to the size of your image. Whatever your image size is or whatever those dimensions are, it will actually resize it so it's not distorted at all. So yeah, it's not enforcing some size that it needs to be. That would be something different that you would have to do. This instead makes it just relative to what we're saying. So if it's 300 wide and 50 tall, it will, or 100 wide or 100 tall and 50 wide, whatever. Basically, it's going to resize that to fit in here, so it's not distorted. That's the main key here, because I think a lot of watermarks work that way. They'll not be super distorted. Okay, so now that we've got that, how do we actually add this onto our frame? Now, wouldn't it be nice to just be able to go, frame.add image and watermark? As far as I know, this doesn't exist. There's no way to actually add that like that, so we have to add it in a different way. And do note that my image and watermark stuff, I'm doing all before this loop, right? So the reason I'm doing it before this loop is because I actually don't need it to be in this loop. I don't need to resize it every frame. I can do it one time and then it's ready to be used throughout. So keep that in mind when you go about doing this. And one other thing I might consider doing is changing my watermark to being, grayscale. So when it actually shows up on my video, it's grayscale. So no matter what color the watermark is, it would be in grayscale. So that's something that we still might do just to think about it. So grayscale watermark. And we could do it there, we could do it after, we resize it, a lot of options. After we resize it is actually probably better, because then it's most likely going to work faster because it's a smaller image that it's going to be working with. So we'll grayscale watermark after that in just a little while. Okay, so now we have to understand how this part's going to work. So what we actually have to do is we have to create something called an overlay. And that overlay has to be the same size of this frame. So whatever size that frame is, it has to be the exact same dimensions. So width and height. That overlay is going to be practically nothing. Once we create that overlay, we are going to replace a certain area with our logo. So a certain amount of pixels with our logo. And then we are going to, replace those pixels in that overlay. And then we're going to put that overlay, or the difference of that overlay, onto our actual frame. It's a lot. I mean, if it sounds like a lot, it is, because we are kind of doing what Photoshop does for us, right? It's taking this like automated drag and drop thing and making it manual. Like, we have to replace individual pixels to work in a certain way, and that's what our overlay is going to do. It is a little bit different than, say, for instance, like putting something over our image. Like if you remember back to drawing that rectangle on our faces, if you did that one with us, drawing the rectangle is a little different than this because we want to add that transparency layer as well. So what we need to understand is how to actually grab a certain area in our frame. Like, how do we actually, identify one part of our frame? You might be familiar with this, you might not be. So if I go into my frame and I select coordinates, let's say, for instance, 50 and 150. So those are the XY values of that frame. So that's the actual pixel value. So if I print this out, it will give me the actual pixel value of that frame. So I'm going to go ahead and save it, and I'm going to go ahead and run it. And what I'm going to try and do is I'm going to try and change those pixel values. So you see them kind of changing, but they're mostly staying the same. If I move my hand over in that general area, you see the colors, the numbers change. Okay, so that's because of the actual pixel value, what's there. So that's not giving me a whole lot, right? Well, what if I made a rectangle that would essentially show me a small block of pixel values, right? So in our faces one, we actually built a rectangle much like that. So I'm going to go ahead and copy that. Not to worry, I will go over all of this stuff in just a moment anyway. So I'll go ahead and copy that and bring it into my watermark and paste this in here. So if you have to stop and, copy and paste and retype all this stuff, that's okay. But essentially we're building a frame or a rectangle in our frame based off of a certain area. Okay, so our coordinates. We had our starting coordinates of 50 and 150. So we'll put those as our start chord X being 50 and start chord Y being 150. And then our end coordinates, we are going to take those start coordinates and then we're going to add a certain, dimension to it. So notice I have W and H, so I'll just say W equals, as in width, equals to 100, H equals to 200. Just to give some little difference of the distortion that would happen. So W, there we go. Okay, so then our frame is obviously our frame. It's the same thing there. If you were using image, like image show up here, right? So watermark would replace this portion, or even the logo red would replace that frame as well. So you can change those things out, no problem. And then this is going to be the color of the stroke, right? So the stroke color and the stroke thickness are there. So the actual border that's happening. So let's take a look at that. Let's save it and run it. And oops, we got X not defined. Of course it's not, because we have start coordinate X is right here. And then start coordinate Y is right here. Okay, so we save that. Let's run it. So that's showing me that frame. Notice there are a little variance in the color. Perhaps this is because of the light that's coming through. Perhaps it's something different. But if I put my hand over that area, we see that the colors do change. And it's only over that one small area, right? So it's like in the top corner, right about that area, I think. Actually, let's just double check the code to see where exactly I did it. So I did it at 50 and 150. So it's actually not even really showing up. I mean, it kind of is, but it's definitely in that top corner, right? So I did that in that top corner. So how do I actually get the pixel values for the entire rectangle? Like, what do I do for that? So what we have to do is take this and get a range of items. So this is actually a NumPy array. And if you're not familiar with NumPy arrays, what you can do is you can take a range within here. So let me just show you what I mean so you can see it. And also maybe it encourages you to learn a little bit more of NumPy. So I'm going to go ahead and copy this original frame, which shows me one pixel value. And now I'm going to get a range of pixel values by using the start coordinate of x to the end coordinate of x, right? So using that colon gives me that 2, okay? And then we are going to do the same thing with the y coordinate. So y coordinate start and the y coordinate end. So this is actually giving me all of the pixel values inside of this rectangle. And keep in mind that since it's inside of this rectangle, it's essentially what OpenCV is doing. It's taking those coordinates and then adding a color to the outside of them. Okay, so let's save that and let's run it. And there we go. So we have those pixel values. They're showing up. It looks funny over there. It does look funny in the code a little bit, but those are the pixel values. And the reason I say it looks funny is because if you're not familiar with NumPy, let's close that out. If you're not familiar with NumPy, then there's a good chance that you aren't familiar with NumPy arrays, which is something that is a little bit outside the context of what we're talking about here. But keep in mind, just think of it in sense of like a big matrix or rows and columns. And in my case, the rows and columns are, pixel value in the very top left corner is this one. Pixel value next to that is the one next to it. And then it goes all the way to the right. And then it does that for the columns as well. So it's getting every little individual pixel value inside of this frame. So why am I telling you this? What's the purpose exactly? Well, because we have to replace pixel values in some sort of area for our watermark to even show up. So that's what we're working towards. And if you don't understand this concept, then you're going to want to stop the video right now, play around with it until you fully understand, maybe with smaller numbers, so you can actually look at it in a different way. And if you're not familiar with NumPy, perhaps you even, import pandas, which allows you to make a data frame out of a NumPy array. Some of you might completely understand what I'm talking about. Some of you might not. But essentially what I'm saying is you can turn this into a CSV file and take a look at each individual pixel value or the RGB colors. Not the RGB, but the BGR value colors, which would go from 0 to 255. You would be able to see each one of them for each individual pixel. Now, do keep in mind that the higher the resolution video you're using, the more pixels you'll have, and therefore the more pixel density, which means a whole lot for what you're building, right? It totally does. It does make a big difference there as far as the size is concerned, and then also as far as your understanding. So we're working with raw pixel values here. It's not the most ideal, but it is what we're going to be building. It's what we're going to be using, unfortunately and fortunately. Okay, so now what we need to do, or now what we need to think about, is our overlay method, okay? I'm going to keep all of these items up here for your own use or understanding, but I'm going to keep them commented out. We no longer need that frame in there at all. It was much more just to understand essentially what it is that we're building toward. So let's go ahead and create our overlay. Now, an overlay is going to be a NumPy array as well. So we need to import NumPy if you haven't already. And we want to create a NumPy array that's essentially all zeros. And it's going to be the same size of our frame. So whatever our frame is, it's going to be that size. So the length and the height and all that. And then we actually have to make it so it can be 4 channels. Now, when I say 4 channels, I mean BGR. So the color, BGR, that's 3 channels. We need to add 1 more channel to that, which would be an alpha channel. So that's what we have to do now. We're going to go ahead and create our overlay. So overlay with 4 channels. That's BGR and alpha. So the transparency level. And to do this, we're going to say overlay equals to mp.zeros. I'll explain the zeros portion in a moment as well. But we're going to say mp.zeros, and then we want to actually make this the same as our current frame. So we want to grab what our frame's shape is. So I'll go ahead and say frame underscore h, frame underscore w, and frame underscore c equals to frame.shape. So we can print out the frame shape to see what I'm talking about here. And again, these are NumPy arrays. So if this stuff's confusing, it's because you might not understand NumPy as well. But I still think you can do this without fully understanding how all of this works, as long as I help you guys figure it out. Okay, so oops, I have this overlay. I want to just comment out that overlay for a moment and just look at the frame.shape. So here it is. Frame.shape gives me 3 different values here. We've got 720, 1280, and 3. Well, what's 720? If we look at our video, well, that's definitely going to be the height. 1280 is going to be the width. We could do all these calculations, but we set that right up here. We set the resolution as 720p. So we should already have known that that's what it's going to be. But the reason I'm doing it this way is to know for sure that it's coming off of whatever my configuration's doing. So I don't have to like think too much, right? I don't have to remember what the height and the width are. And this is the shape of the array. So when we grab those pixel values, that individual item, that's getting the first portion of that frame or that array, and it returns back that final one, which would be that third aspect. I realize we're kind of going in the weeds here a little bit, but the third one is the RGB values, or the third part of this matrix is those RGB values. So I do want to show you that we might have to actually see this in gray to see this frame shape as well. So let's go ahead and just look at the grayscale version, and it's going to be cv2.convert color of the frame. And I'll just do frame.copy. So we're going to copy the actual frame here. And then we'll do cv2.color BGR and then 2 gray. And then here I'm going to go ahead and print gray.shape. We save that. We run it. And now what we see is the 3 is still there. And then we have this other one with no shape. So really it's just 1. And that also means that it doesn't have a channel. So if we went to look for this channel, we wouldn't find it. It should give us an error here. So if I did gray.shape and try to do it now, it gives us an error. Okay. So this is actually important when it comes to working with our grayscale image. Okay. If you end up using something in grayscale, this portion's not going to necessarily work out the way we hope. So that's something to consider when we were talking about changing the image to grayscale. That might play into some issue later or in the near future. Okay, so let's go ahead and ignore that now. Now hopefully we understand that we have the height, the width, and then the channels or the channel layer, which in our case is BGR, so it's the color layer. And if we used grayscale, we wouldn't even have one of those because there is no color. So the shape is different. It would be a shape of 2 items instead of 3. Okay, so that's important for what we're about to do, which is our overlay. NumPy zeros, we are going to use the the shape of it, the first part of the shape, which is frame height and frame width. And then instead of using 3, which was on our original channel, we are going to be using 4. So this is, comma 4 here. So this is our new shape. That's the new shape it is, because now we're going to have another channel. That's the alpha channel. So what it was is 3, now it's 4. Of course, if I was doing grayscale, what it was is it's really just 1, but it treats it as 0. Instead of 1, it would be 2. That might come into play later. It might not. But essentially, I'm just adding one channel to the BGR. So instead of having my color being 25500, it'd be 250001 or whatever alpha that I end up using. And then we want to set our data type being to just uint 8. Cool. Whew. Okay, so we've got our overlay. We have generally what it's going to be, and it has 4 channels. So in order for me to actually add something to this overlay, such as my watermark, I have to update my watermark's channels as well. So going back up, I'm going to change the watermark again. So watermark equaling to, and this is cv2.convert color of the original watermark. And we're going to do cv2.color underscore BGR2 BGRA. Save that. Okay, and now we're going to go ahead and run it. See the watermark. Let's see it. It pretty much looks the same. We changed it to being BGR2A. And now let's just look at that shape. I'll just go ahead and do print watermark.shape. Save it. Run it. And it should have printed one time, and it did. It's right up here. So it gives us a height and width and that 4th channel. Much like this overlay. Now, granted, if you went back and you printed the shape before we did that conversion, you would see a number 3. So this conversion is critical for this one, so we can have the alpha channel, or that final pixel value, being the same on the overlay as well as the watermark. Okay, now what we need to do is we need to replace the pixel values in this overlay. So let's look at the overlays just so you can have an idea of what it looks like. So cv2.im show and overlay, and then overlay. Okay, we're going to save that, and I'm going to go ahead and not show anything else. Not going to show the watermark or anything, just the overlay. And there it is. It's all black. So that's what the zeros do. They make it all black. So NP zeros means that all of the BGR frame, everything at the end is all zeros. So we declared these two, but all of these values are equal to 0. Every pixel value is equal to 0, and that's what this overlay did. You could change individual pixels to something different. So let's actually change a range of pixels to something different, much like what we did up here. So I'm just going to take a random range, and I'll just say 250, or rather let's do 100 to 250, and then let's do 100 to 100, or no, 100 to 125. Okay, and then we're going to set that equal to some BGR value. Well, let's go ahead and just come in here and do 0, 0 like that. We'll save it, and we're going to try this out. Let's go ahead and run it. And there we go. We've changed the pixel values on this overlay to this blue color. And if we go back to our code, of course, that's because it's B as in blue, G as in green, R as in red, and then the alpha. So we can change those colors if we'd like. So let's go ahead and change it. But another thing that you may have noticed is it seems that this is not actually X and this is not actually Y. And that's actually correct. So they are inverse. I had them written incorrectly. So this is actually Y and this is actually X. Now, the reason I showed you this is a couple things. Sometimes you forget which way they go because this is frame H, frame W, and that's actually the shape of it, right? So it does do the height and width in reverse of what you may think, or at least in the reverse of what I think. But then the rectangle is the other way, right? So when we drew that rectangle, it was correct. So it gets a little bit confusing sometimes as to where the starting coordinate and where the ending coordinate are. But what we can do is just realize that the height one is first and then the x1 is second. So if we wanted to make another block, I could go ahead and copy this, paste below, and do the x starting, which would be, let's do it at 150, and keep everything else pretty much the same, 150 to 255. That's fine. And then we'll just change the color here a little bit. Save that, and then we'll go ahead and run it again. And what we see is now, those two blocks there. So just a little note as to how this portion changes. We're just going to go ahead and put start Y and end Y. And end Y and X both have to be bigger than their starting coordinates. X and then end X. Okay. And then we want our B, G, R, A. So why did we create this overlay, and what was like the real motivation behind it? Well, this overlay, we can use a CV2 method to add this overlay to our frame, and then there will be a way to essentially make one of them have an alpha level, that is, make the entire thing, the entire overlay with everything on it, which would include these colors here. We would be able to change the alpha as to what it is. Like we started out with just an alpha of 1, so we can make it like 25% of what it is. And all of that black will actually be ignored because of how this method works. So CV2.add weighted, and we want to add the overlay first. So overlay, and then whatever weighted value we want to add. So I'll do 0.25. And then we want to add the frame. And then again, if we want a weighted value there as well, we can. And then I'm just going to add 0. And then the final output is the frame. So intuitively, this is what would make sense, right? I'm taking this overlay I just created, and I'm going to add it on top of that frame. And since the overlay and the frame are the exact same size as denoted here, this should work just fine. Or should it? So let's go ahead and save it. And let's go ahead and run it. And I get this error, this array or op scalar. Like, what the heck does that mean? Well, there's a chance that you intuitively know what this is. But when I was learning this, I did not. I was like, hey, what is going on here? Well, what happens with OpenCV is we have to treat the things that we're combining the same. So I mentioned before about the possibility of an issue with this grayscale. Well, the same thing is true with alpha. So when we create an alpha overlay, our frame has to match that overlay. And right now it doesn't. If you remember back to the frame shape, the shape would be, the frame C would be a shape of 3. So we can quickly change that, or very easily change that, by doing frame equals to cv2.convertColor, and this is going to be the frame, and then cv2.color to BGRA. Just like what we did with the watermark, we have to do that with the frame. And yes, I have to do it on every single one. There actually might be a way to do it prior, so I'm actually not sure about that for sure. But I do know that I need to do this on here. And since I'm doing the overlay and all that stuff too, I want to make sure that all of this stuff is working together, and it should work fine. Okay, so let's go ahead and give it a shot after we save it. And now what we've got is our overlay here, and it's showing me my overlay, and it's not showing it on the frame per se because all we showed was the overlay. So let's go ahead and get rid of that show. And now let's actually put the frame out there with this added weighted overlay, and we bring in the watermark, and there it is. So that actually shows us those items. And notice all the black is gone, right? But the overlay is still absolutely working. It's still working, and it's working great, and it's just there, right? So how do we take this same concept and bring it into our logo or our actual, the watermark that we actually want to use? So this is where it gets a little bit more tricky. What we have to do is something very similar to what we did here, but we have to do it for the actual logo itself. And there's definitely other methods on how to do what I'm about to do, but I want to show you the method that will probably be the easiest to explain and therefore the easiest to understand. So we want to get the height, or we want to get the shape of the logo, much like we got the shape of the frame. So the shape of the watermark, let's go ahead and grab that and come down here, and we'll go ahead and say we'll do watermark H and then watermark W. Well, let's actually call it watermark, and that way we can really distinguish these things. And then finally, watermark C. And that's going to be equal to the watermark frame. Now, since we already made the watermark into the alpha channel version, this should be fine, right? So these things should all be equal. So it should be equal to the actual overlay for OpenCV. So what I want to do is I want to replace the pixel values in the overlay that match with this watermark frame. So the very first thing that I'm going to do is I'm going to go ahead and say for I in range of 0 to the watermark H. So this is going to iterate through every number between 0 and however big the watermark is. So it might be 50, it might be 100. It's just depending on how big this H is. Okay. And then what we want to do is that same idea for J in range 0 and watermark W. So same thing with the width. So we're doing the height and the width. So this is getting all of those pixels in there. So every time it does an iteration, it has a new pixel value. So that pixel value will be related to the height and width. So in other words, watermark of that pixel value, so I and J, or the height and J, so this gives me some sort of pixel value. This will give me some sort of RBGA value, in other words, right? So what this means then is I would be able to, in theory, go to the overlay and change it based off of this. So overlay of I and J, so those pixel values equaling to the watermark of I and J. Again, so each pixel value. So it's similar to like this range here, right? So we have this range up here that's actually doing that for us, right? So this is doing the range, but what I mentioned before with the frame, we can get an individual spot or an individual pixel, and that's what this is doing. It's getting an individual pixel, and it's setting that equal to the same individual pixel on the watermark. So the watermark logo and the overlay itself. Okay, so this may work, but it also might not, because if you remember how we actually used our watermark, well, we have a JPEG image here. Initially, we have a JPEG, so this should work fine. So let's go ahead and try it out. I'll go ahead and save it. I'm going to get rid of these other colors here. Save it there. And we'll run it. And I get an issue or an error here. So we've got a watermark. The watermark frame is not wanting to show us, saying that we don't have a watermark frame. Oh, of course, it's not frame, it's shape. I'm like looking up here, going, what's going on? Okay, it's shape, obviously. Okay, cool. So now, what do we see here? We have my actual item on here, but I'm using the JPEG, right? So the JPEG, that's this right here, right? Or sorry, this right here. And that's actually showing me the watermark. If we were just doing a JPEG, that would be fine. We would be done. But we're not doing a JPEG. We want a PNG, which has its own alpha channel. In other words, it has actual values for alpha, where the JPEG doesn't. Everything in a JPEG is just one for the alpha channel. So for that last channel, it's always one, much like what we saw up here. But with a PNG, that's not true. With a PNG, we actually can have a 0 value somewhere. So what I want to do is say if that watermark pixel value, the actual item in there, the third item, I'll show you this in a second, I want to say not equal to 0, then I'm going to go ahead and use my overlay. And only then, and that's going to be for my PNG, but this will work with the JPEG as well, because we want a number of 1 there. In other words, let's go ahead and just print out what that pixel value is each time. And we'll just go print what that pixel value is. And in some cases, it's going to be 1. Some cases, it's going to be 3. It actually doesn't matter what number it is, because with the PNG, as long as it's not 0, we want to actually replace it or show it. So we add this in, and okay, so I cut it out. Notice that there's a bunch of zeros. There's 196. There's zeros and all the way up. So that is showing us our actual pixel value. So let's run it again. And I should see my watermark. It's now showing. It's actually working. So it has a little bit of delay, and it's the reason for the delay is this print statement. So if we get rid of that print statement, the image on my video while I'm recording is working. So this will have a difference on, your system depending on what system you're using. So now what we want to do is change the location of where that watermark is going to be based off of the actual frame. So we have our entire frame. In other words, I want to put this watermark instead of the top left corner. I want to put it at the bottom right corner. And something I really haven't explained a whole lot yet, but hopefully you have intuitively understood it. Up here, this top left corner is actually X0 and Y0. And then the bottom right corner would be whatever height and width it is itself. So we want to move this overlay there. Let's just try something like this. We'll just use one number, and I'll do consistent numbers on all of them. So essentially what I'm doing here is I'm adding just a random value to my overlay to see if I can even move it, right? So if I can move the watermark. And I did. I moved it down 100 and over 150. But what I want to do is I want to move it. Let's run it again. What I want to do is I want to move it down to this corner. And I want it to work based off of whatever the image size is. So in other words, I want it to be based off of the frame itself. So what that means is then I need to have like a height offset. So we'll do H offset equals to, well, it's going to be the frame itself. So that's the entire frame. And if I just left it at that, what's going to happen? Well, it's going to go all the way off screen. So it's going to actually take it off of where I currently am. That's not great. So what I need to do is factor in the watermark height as well. So I need to make sure I remove that watermark height also. So with that, if I save it and run it, what I should see is that now it's on the bottom. Right? It's on the very bottom. It's actually touching the bottom. And of course, I can do the same thing with my X offset, or let's call it the width offset, and frame W, watermark W, and change that 150 to that. We save it and we run it. And where's this going to go? It's right there in the corner, right? Right there. Cool. So it's actually showing us exactly where we want. But you might want to make one little additional thing, which is like just an extra offset of like 10, something along those lines, and then subtract that as well. And what this is going to do is just bring it up a little bit out of, so it's not right in the gutter of it, and it's just right off the side there. And you might notice this little like white, this little white outline and stuff like that. That might have something to do with my image, or the fact that this method isn't perfect. It's not completely foolproof, but it does work, and it works decently well considering what we've done so far. So that is actually creating the watermark. Now, obviously, the final step would be actually adding this to a video, which is really simple. We just add in that right frame there, and let's save it, and we'll run it again. And there it is, the watermark's there. We're testing it out, doing some things here. It should work just fine. And there it is. Okay, so now let's go ahead and look at that video. And I'm going to go ahead and open it up. And we get an error. Okay, so looks like we have an error with the writing of the frame. It's possible it has to do with that alpha channel. So let's go ahead and do CV2 and convert color frame. And it's going to be CV2.color from BGRA to BGR itself. And we'll just say frame is equal to that. And let's try that one out. And watermark's still there. Let's look at the video. And sure enough, the video's working. Also with my watermark. Let me just make it a little bit bigger so I can see it. And there's my watermark. It's right in there and it's working fine. Okay, so now the thought is like, well, how would I actually turn this watermark into grayscale? And also, how did I know that that's probably why this wasn't being saved? Well, the reason I knew that this was probably not being saved is because the frame was saving fine before I converted the frame to something different. And the reason I can convert it again is because I converted it up here, and all I do is just convert it back. So I add a bunch of stuff to it and then convert it back to its original color. So how do we do that with grayscale? Like, how would I actually turn this into a grayscale image and then work off of that? Well, let's just try something. I'll just say watermark equals to cv2.convert color of the watermark, and we'll do cv2.color, and this is going to be BGR to gray. And then watermark equals to cv2.convert color of that watermark, the one right before it, cv2.color, and I'll just do gray to BGR. And let's see if that works. Actually, not sure if it will, but it does. So yeah, notice that the color, it did keep the white, didn't keep the white. So it actually did change the color, but it didn't keep the actual white, like the transparent white portion. And that's because of this part right here. So what we might be able to do is down here is, instead of setting it to being whatever that pixel value is, we could set it to being gray. Now this might run into some issues. Like in this case, it might run into some issues with how the logo actually looks. In my case, my logo does actually have white, so I can have some conditions for that. Or I could go back and do some pre-processing and change those into being transparent as well. So then it's a 2-color transparency. And then in here, we would just set the RGBA value to whatever gray is, and that would do it. I'm actually not going to do that because I'm not really worried about that grayscale portion. But basically, this is how you're going to want to convert it from white to gray if you don't mind that background being white as well. Or in here, this is where you would convert it to changing the actual color value itself. Another thing is too, you could make a condition for this pixel. If that pixel equals to white, you keep it white. Every other color, you turn it to gray. In other words, you can make your own grayscale sort of method inside of this iteration to do that. Now, I did mention that this is probably not the most efficient way to create your watermark. Because it's going through the size of the watermark every time. And if we had the watermark being a little bit bigger, let's say like 250, and we ran it now, it might run into some issues. Like, look at it, now it's super choppy, right? So maybe you can tell, maybe not, but now it's super choppy. So yeah, that is definitely not the most efficient way to do it, whether it's on an image or a video, but it is a way to do it that I think helped explain that concept a little bit more. So hopefully what you'll see in the code in the near future is a more efficient method of replacing those areas. And it's going to be related to this overlay itself. But I want to put that on the code so you guys can see both methods. I just have to do some more research on it. So that's still coming. All right, so thanks so much for watching about this watermark and overlay methodology. I took a lot of different sources online. I just read a ton of stuff to try and understand this as best as possible so you guys can understand it as well. So realize that if you do see this in somewhere else, there's a good chance that I learned from that, as well as the OpenCV documentation. I think that's a really good reference to understand these things too. But I'm explaining it to you so we can both know exactly how I did this method. And also, I mean, yes, it's complicated. There is more work that has to be done than a simple video recording, but it was pretty easy overall. And you can use this, you can absolutely use this on images as well. So for those of you who need to do a back-end processing using something like Django and you want to add a watermark to everything, OpenCV might be something that you use, but you also might just end up using something like PIL, the Python image library. I think that actually might have an easier method to do it. But for us, we do want to understand a little bit more about OpenCV. So that's why building and creating this will be good for us in the long term. So I'm going to leave this watermark.py. I'm actually going to call this watermark video or watermark lesson.py on the live one. And then I'll actually have a condensed version called watermark.py when we, so you can use it in real practice in the future. Thanks for watching.